As you can see, there's already been a couple buildings that have come down. Those buildings have all come down what's considered mechanically. They've come down with excavators that's broke up the concrete, that's sheared the steel, separated out the materials to enhance a lot of the recycling efforts that's went into this project. And a lot of the current efforts that are going on and the efforts that are going on, you can see back behind me here is actually the preparation for the implosion of UHall. And UHall was a building that, as we were looking at this project initially, we really had to consider from a engineering standpoint as to how we wanted to bring the structure down. The building wasn't so tall that we couldn't reach it. It wasn't so large that we didn't have the excavators for doing it, but there was a portion of this structure that had been altered. At the top of a lot of dome structures, there's what's called a ring beam at the top of the structure, and that's a post-tension structural element to the top of it that gives a support to the actual dome itself. This structure had been altered at some point in time after its initial construction, and the engineering and things that we were doing at the time really kind of didn't bring a lot of clarity as to bringing this structure down mechanically. And thus was the reason that we decided to bring this particular structure down with implosion. So the work that's been happening, that's been going on here, is a lot of the preparations. We remove a lot of the non-essential elements out of the buildings, non-structural, non-load-bearing walls, things that are interior of the building that are really not helping the structure stand. We want to strip it all the way down to its bare bones, its bare frame, and then from there we actually weaken some of the structure, and then we go in and drill holes into those structures, which is where the explosives will be loaded. Inside of there, you will see within the structure, it's now a large curtain that's being held up all the way around it. That curtain is a combination of chain link fence and geotextile fabric. And what that is to do is to help with, when the implosion does go off, it helps with any type of flying debris. It helps to control, to the best of our ability, the dust and things that were going to come out of this building as the implosion takes place. So one of the things that we had to really take into account with this particular structure was the protection around the area. When we look at a building, we have to look at, are we trying to protect buildings? Are we trying to protect infrastructure? Are we trying to protect elements that can't be moved? And in this particular one, there was the McHugh on the backside that has an electrical transformer that's very, very close to this structure. The McHugh building itself that is close, and then we have all the practice facilities that's very close. So the design of this implosion has really been done to help bring the structure away from those buildings as it's imploded. Sometimes people think we just kind of go in and strap some dynamite on them like they do in the cartoons and the thing blows up. But there's a lot more science, there's a lot more engineering that goes into it than that. The charges are actually all timed down to the millisecond as far as how they're going to go off, in what order they're going to go off, and that's to help to create movement. The implosion itself is to create movement within the building, to create the direction that we want the structure to fall. We're trying to weaken the building beyond what it can handle its own weight, and then let the weight of the structure itself bring it down. So we're not trying to blow it up into a bunch of little pieces. We're actually just trying to fail the building enough for the actual weight of it itself to bring itself down. And that's part of the safety that goes into the implosion of the structure, that we're really not trying to break it up into a lot of small pieces. All we're really trying to do is to control the structure as we're bringing it down, and to bring it down as safely as possible. So all of that's going to happen. There's a lot of pre-work that's going to happen, continuing now through early morning hours of the implosion at 10 a.m. on Saturday. And it'll be Saturday where you're going to start to see early morning a lot of restrictions that I believe the university has gone over, and will continue to go over a lot of the road closures, sweeping the buildings to keep people out, make sure nobody is within a building prior to the implosion. But once the implosion does happen on the morning of, you'll hear a roll call and a countdown. The building will go up. You'll see a large dust cloud that will come up and develop over top of the structure, which is very normal. Depending upon the prevailing winds will determine how long that dust cloud remains. If there's not a lot of wind, that dust cloud might last for 5 to 10 minutes. If there's some wind, probably closer to the 5-minute mark. But it really all has to do with the wind conditions on those particular days. After the structure is down, it's just going to be a large heap of rubble at that point in time. The same equipment that you see operating back behind me that was used in bringing these other structures down will go in and continue the recycling operations of pulling out and separating metals, separating concrete that all goes out to be recycled. And then it'll begin the cleanup of the overall site and restoration to a green area that we will be leaving the structure in, or leaving the property in.